Okay, these last three functions in 1.3 are trig functions, so I just want to address them and use the calculator and talk about some of the trig items that you should remember from pre-calc. The first one here is the limit as x is approaching positive infinity of the sine of x. So what you need to remember is that you need to graph your sine function. So if you consider this would be base, max, base, min, base. This is one cycle. So remember, this is as x is approaching positive infinity. So as I sketch my graph here, what you're looking for is as x is getting infinitely larger, is your y value approaching the same value? So if you look here, y is equal to 0, y is equal to 1, y is equal to 0, y is equal to -1, 0, 1, and so on. So in this case, your graph is oscillating. Okay, so the sine of x is considered an oscillating function. Okay, so the problem is that it will never settle on one specific value. So the limit as x approaches positive infinity of the sine of x does not exist. One thing you might want to consider, does the same thing happen to the cosine of x? Okay, let's take a look at this next one. The limit as x is approaching positive infinity of the cosine of x over x. So right now you don't know technically any of the properties that we could be using, so we're going to use our calculator. So what I did was I went into y equals and I put this function into the calculator, okay, so that you can see it. All right, so I could look at the graph, but this is kind of hard to tell. I don't really know what's happening. So if I go into my second window, which is the table setup, and I change the independent variable from auto to ask, what this allows me to do is specifically ask for values in my x value. So what's going to happen is if you do this, your table will be blank. So if we're looking at the values of x as x gets really, really big, you want to see what is the trend, what is happening here. So let's just put in 10. Okay, it's a small negative number. Put in 100. Okay, even smaller. Put in 1,000. Okay, what you need to think about is, what does this mean? 5.6 times 10 to the -4th power. Really small number. Okay, so 10,000. Even smaller number. Okay? Even smaller. So now you need to conclude what's happening. I think at some point you can't handle it. Okay, but that's even smaller. All right, let's see. Yep, see an error because it just can't handle it's so small it can't handle the number. But really, I'm just looking, I don't have to do it this many times. I'm just looking to see what is happening. So in this case, the trend is that your values for y are approaching 0. Okay, even though it'll oscillate just a little bit, this is the trend. In this last question, we're looking at the limit as x is approaching negative infinity of my inverse tangent and as x is approaching positive infinity of my inverse tangent. So what you really need to do in this case is just think about the graph. So if we're looking at y is equal to the tangent of x, for those of us that really didn't like the graphing portion of pre-calc, remember this looks like an x cubed graph. So it goes like this. Okay, and I know that this is the tangent of x, but what happens is everything just basically flips, meaning instead of vertical asymptotes, I have horizontal asymptotes. And then instead of in this direction, my graph goes in this direction. So if you know your parent functions, you can actually answer these questions a lot faster because sometimes putting them in the calculator is not an option. So I'm looking at the limit as x is approaching negative infinity. So my x values are getting smaller, 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 right here. Okay. What are my y values doing? My y values are approaching -π/2. That's my horizontal asymptote. Okay, so then when you take a look at as x is approaching positive infinity, you're looking at the trend of the graph. Where's the graph going? Towards π/2. Okay, we'll cover exponential and logarithmics live in class.